Today we're going to start talking about trigonometry, and trigonometry is this huge and hugely important area of mathematics that relates angles with distances. And this has applications everywhere, from ship and plane navigation to the phone calls that you make on your cell phone to just about everything that NASA ever does. And so it's a big and long journey that we're going to go on. And we start off with angles, and we're going to just get some angle vocabulary going on here today. All right, so I have an angle here drawn, and I've given it a name which looks like a little fish. That's a Greek letter alpha. We frequently use lowercase Greek letters for the names of angles. And let's get some terminology going on here. The beginning side of this angle is what we call the initial side. And then that arrow lets me know that this rotated counterclockwise, and it lands on what we call the terminal side. And then the place where those two sides meet is called the vertex. We kind of borrow that word from parabolas. All right, so I'm going to take this angle and I'm going to draw it in what we call standard position. So I've copied this angle and I'm going to paste it over here. And then I'm going to rotate this angle so that the initial side is going completely horizontal. Okay, so see if it'll let me do this. There we go. And then I'm going to throw the X and Y axes on here so that they are going through the vertex. Here's the Y axis. And the X axis is right there. So my X axis, my Y axis. Okay, so when you do this, when you put the vertex at the origin and the initial side on the positive X axis, then you've got it in standard position. All right. And this angle here, alpha, let's give it its name. Alpha is a positive angle. We call alpha a positive angle because it rotates counterclockwise. And then if we give this a measurement, like this looks like it's a little more than 90 degrees, let's say 110 degrees, we would give that a positive 110 degree measurement. So negative angles go clockwise. All right, so let's get some practice drawing angles in standard position. All right, so here I've got three angles, theta, alpha, and beta. So again, lowercase Greek letters that we see. And we want to draw these in standard position. So we know that we're going to start at the positive x-axis. For 150, that's a positive degree measurement. We're going to rotate counterclockwise 150 degrees. Now, 150 is more than 90, and it's less than 180, a little bit closer to 180 than it is to 90. So I'm going to guess that it's about right here. Okay, so when you draw these angles, it's important that you include that arrow that tells you which way it's rotating, because you could land at the same terminal side by rotating either clockwise or counterclockwise. We just have a different angle measurement, one positive and one negative. All right, so what about negative 80 degrees? That one's negative, so we're going to rotate clockwise. And let's see, we don't want to go quite 90 degrees, so we're going to stop. We're just shy of negative 90 degrees. Again, our arrow for rotation, and label it with its name. 450 degrees, that's more than a full circle, right? So we need to figure out how much more than a full circle. So you want to subtract either mentally or we'll write it down. That gives me 90 degrees. Okay, so this angle beta is going to make a full circle 360 plus another 90. Okay, so counterclockwise, because it's a positive 450, a full circle plus 90 degrees, and that's our beta. Okay, so you can also see here why that arrow is very important, because it signifies that this is a 450 degree angle rather than just a 90 degree angle. And even though those two angles land you in the same spot, they're not the same angle. Like if you're on a skateboard, going 90 degrees is not the same thing as doing 450 degree turn. All right. The last bit of terminology I want to put on this slide, we say that this angle theta over here is in quadrant 2. Obviously that angle spans through quadrant 1 and quadrant 2, but when we say that an angle is in a quadrant, we mean you drew it in standard position and the terminal side landed in quadrant 2. And then alpha, we would say, is in quadrant 4. Then beta obviously takes up all 4 quadrants at one time or another, but it doesn't actually land in any one. Its terminal side is on the positive y-axis. So if your terminal side lands on either the positive or negative x or y axes, you call this a quadrantal angle. So beta is quadrantal. Our last vocabulary word for the angles section is going to be coterminal. So two angles are coterminal if, when drawn in standard position, their terminal sides coincide. All right, so I've got an angle drawn here that lies in quadrant 3. It's a positive angle because it's rotating counterclockwise. If I wanted to find a coterminal angle, it would be any other angle in the world that has exactly the same terminal side. So I could draw a negative angle that would meet at the same place that has a different measurement. It's a smaller angle, has less degrees, and it has a negative measurement, but lands you at the same spot as the original angle. We could also draw like one that goes a full circle and then stops at that terminal side. This is getting a little too crowded for me to draw us another one, but we could do a negative angle that's going to do a full circle and then make it over to the same terminal side. All right, so you could do as many full circles in either direction that you wanted to and then stop at this terminal side. So any angle actually has an infinite number of angles that are coterminal with it. Usually we just want to find one or two. All right, let's start by finding two angles that are coterminal to 60 degrees. So let's draw ourselves a 60-degree angle and see what's going on here. So 60 degrees is less than 90, but it's more than halfway to 90. So positive means counterclockwise. There's my 60-degree angle. All right, and the trick with coterminal angles is going to end up being either adding or subtracting a full revolution. So let me write that down and then I'll show you why it works. So to find coterminal angles, you're just going to take your angle and you're going to add or subtract 360 degrees as many times as you feel like it. Okay, so adding makes sense. If I take 60 degrees and then I add a full revolution to it, that's just going to land you at the same spot, right? So I would do 60 degrees plus an extra 360 degrees to get 420. Okay. Okay, so what does subtracting 360 degrees do? If I take 60 and subtract 360, kind of actually need to subtract up, right? So that would give me negative 300 degrees, right? That is this angle right here, okay? But what subtracting 360 degrees did, it said, okay, go your 60 degrees, but then make a full negative revolution this way. Okay, so it kind of lopped off the 60 that was in the positive direction. All right, but all you have to do to find coterminal angles is to just add or subtract 360 degrees as many times as you feel like. All right, so let's see if our trick works without having to draw the angle. So find two angles coterminal to negative 150 degrees. So negative 150 degrees, we can either add or subtract 360 degrees. So I'm going to add 360 degrees, put that positive one on top. So we're actually subtracting 150. So I get 0, 1, 210 degrees. And then what if I subtract? So if I do 150, negative 150 minus 360, it's really adding and keeping them both negative, right? So 11 carrying my 1, 510, negative 510. Let's draw all three of these angles and make sure it makes sense that we're doing coterminal angles. So negative 150 degrees, that is a clockwise angle. It's less than 180, so it's going to land you over here in quadrant 3. The positive angle was 210. That actually makes sense clockwise because it's positive. And a little bit more than 180. 210 is a little more than 180. The negative angle, this is the angle that goes negative 150 and then another negative full revolution. That's negative 510. Okay, so you don't need to graph these to find coterminal angles. You can just add or subtract 360 degrees as many times as you want.